Going on now to section 3 of chapter 6. And here they are officially opening the slope-intercept form. And just for review, it's y equals mx plus b, where the m is going to be the slope, and the b, as we've mentioned, is the y-intercept. And we also had ax plus by equals c was the standard form. And if we solve for the letter y in any equation like this, it then becomes the slope-intercept form. Just a little background here. Let's go on to our next slide. So we're going to interpret the slope of a line as a rate of change, calculate the slope of a line given 2 points that lie on the line, find the slope of the and graph horizontal and vertical lines, recognize that this is the slope-intercept form that we just reviewed. Okay, so what is slope? Well, if you've ever been skiing, you know that slope is something you want to have when you go skiing and you go downhill. And of course, to get downhill, you had to go uphill. So this is sort of what slope, the slant of something. And we can also have a horizontal slant, and we can also have a straight up and down. That's a vertical line, horizontal line. This one, when it starts low and goes up, is positive slope. And this one, when it starts high and goes down as it goes to the right, is negative slope. And we'll be repeating this, a little bit of background. So on a graph, as we think of slope, and we use the letter m to define slope, it's actually y units, which are the up and down, the rise, over the run, which is the horizontal movement, that is the x. So if we have two ordered pairs, and we designate one of them as the sub-1s, and the other as the sub-2s, we could put it in this typical formula. And this is one you should have in your notes, and we will be using here shortly. You can pause. So, find this slope. Now, they've worked it out for us, but I'd like to work some of this out too. So these are the sub-2s. So it's, once again, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you would need to write this a couple of times to get some practice in it. And generally I just take it like this. This is my sub 2, so that would be 5. Minus is in the formula, 2. And then I go to my x, 3. Minus is in the formula, but notice that our x term here is a negative 1. So the opposite of a negative 1 makes this a plus 1. Now you could write it out negative 1, or you can just write it like this. So this is going to be 3, and this is going to be 4. So our slope is rise of 3 over run of 4. And there it is. All right, here's just another example. Now remember, if this is a quiz question, and I give you these points, you already have it worked out. So 2 minus 5, and then 5 no, I should say a negative 1 minus 3. So this now becomes a negative 3 over negative 4, which becomes a positive 3/4. So if we designate the other ordered pair as the sub 2's, it works out the same. So you can do it either way, and that's what they're showing you here. Now, another thing we might note, if we plot these points on a graph, 3, 5, so 1, 2, 3, and then 1, 2, 3, 4, 5 is this point, and negative 1, 2, negative 1, up 2. We get these 2 points. Notice that we can actually, in a sense, let me draw this for you. This would be the run 1, 2, 3, 4, and then we go up 1, 2, 3. We can figure the slope just by using the grid marks and making a little right triangle. Actually, in other courses, you have to figure out the length of this. It's diagonal, where we use the Pythagorean theorem, but we're not doing that here. We're just figuring the slope. So up our y units, run x units. And notice we went from here in a positive direction and here in a positive direction. Now if we started here, going down would be a negative direction, and then going to the left would be negative direction. And that would be negative over a negative, but that still equals positive 3/4. So starting low, and as you go to the right, the line rises. This is positive slope. All right. So in this next example, here are our points. We'll designate that as the sub 1's, and this is the sub 2's. So we're going to have 1 minus 3. Then we're going to have 5 minus 1. So as we do the calculation, this is going to be a negative 2 over 4. And that reduces to a negative 1/2. So the slope is a negative 1/2. And now they're going to ask us to plot these on a graph and get the actual line. So let's do that. And they have nice a display here. So there's the negative 1/2. Now there's our 2 points. Now notice this is negative slope. So it's starting high and going down. Now again, you're making a little right triangle here. That this is a rise and this is a run. So if you start here, going in this direction is a negative 2, but going in this direction, let's put that there, negative 2, going in this direction is a positive 4. Now if you went this direction, that would be a negative 4. And then if you went this way, that would be a positive 2. But either way, it comes out to a negative 1/2. Negative 1/2. Only one negative makes it a negative slope. Starts high, and as you go to the right, goes down. And here they're giving us a note referring to what we've just illustrated. All right, now we're going to take a quick look at horizontal and vertical lines. Now, they have a special formula associated with them, and take some notes because the question might be, what is the formula for a horizontal line? And you're going to write this: y equals b. And we're defining the slope of a horizontal line as 0. And the other thing to note, what is the formula for a vertical line? And the formula for that is x equals a. Now, a little hint, too, as we had said before, the ordered pair is x comma y, but we said that sometimes we write that ordered pair as a comma b. So if they said, make a graph of the equation that is with 0 slope, and going through this ordered pair, 3 comma negative 2, the equation would be, again, horizontal line, 0 slope. We're going to use the y, and the value that's in the y, or the b value, is negative 2. Now, suppose we ask for a vertical line going through this particular point. Well, that equation is going to be x equals, now remember, we're looking for the a value, which is 3 here, x equals 3. Now, what would this graph look like? Let's just do these while we're here, too. So, x equals 3 is a vertical line going through 3. And a horizontal line, y equals negative 2, negative 1, negative 2. I didn't do that one too well. Close enough. Is a horizontal line going through negative 2. Now, keep in mind we said that B is your y-intercept. And we said A is your x-intercept. So a little bit of background. Again, pause as needed. Get some good notes here. Now, find an equation and slope of a horizontal line going through this point. So, good practice now. This is A comma B, and a horizontal line equation is y equals b. So the equation is going to be y equals 5. And that would be a horizontal line, 1, 2, 3, 4, 5, going through 5. Now, what is the slope of every horizontal line? The slope is 0. And in addition to taking notes, later you want to study these notes. So, you get some mastery of this here. And there's an equation there. Okay, find the equation and the slope of a vertical line now. Well, again, this is a comma b, and the equation of a vertical line is x equals a. So it's going to be x equals our a value, which is 3, and that's a vertical line going through 3. Pause is needed. And we didn't define the slope, but the slope of every vertical line is undefined. Now, the slope-intercept form, and hopefully now through repetition, you're picking up on it, is y equals mx plus b, where m is the slope and b is the y-intercept. And they're showing how to write the formal way of the y-intercept. X is 0, and then whatever the value b is, which is your y value, that is your y-intercept. So find the slope and y-intercept of this equation and then graph the line. So for something like this is in standard form. We want to solve it. Let me write it out here for you. 2x plus 3y equals 6. Now, to go from standard form to slope-intercept form, we have to just solve for this y right here. And we did some of that in an earlier chapter. We're going to transpose the 2x to the other side, negative 2x. So we get 3y equals, transpose this to the other side, 2x. On the other side, just change the sign, plus 6. Now, to get the y by itself, we just divide everything by 3. Simplify, we get y equals 2/3 x plus 2. So now this is our slope, and this is our y-intercept. And they want us to graph this. Now, there is a special way of graphing this. Theoretically, you could make a t-chart. In fact, from this, it's easy to make that x and y intercept t-chart. But when you have solved for y, and you know the slope, and you know the y-intercept, there's a shortcut to graphing this. And here it is the recipe. Step 1, plot the y-intercept. 1, 2. The y-intercept is 2. Now, this is positive. So we know there's 3 run units. So I just go 3. 1, 2, 3. And there are 2 rise units. So I just go up 2, 1, 2. And then there's my line here. So this is a shortcut method of graphing it. Now, what we found here, of course, if x is 0 here, if x is 0, where are we? Over here. If x is 0, your y-intercept is 2, which is what we said. Now, we didn't know the x-intercept here, but we could figure that out. If y is 0 here, we're going to divide both sides by a -2, so this becomes a -3. So over here we have 1, 2, 3. There's our x-intercept. So in graphing, there are a number of ways. You can make the traditional t-chart. You can make the x and y-intercept t-chart. And you can solve the equation for y, get the slope and the y-intercept, plot the y-intercept, and then put the slope to get your second point, and then your graph forms. All right. So they're solving it for y, and there's our slope-intercept form. And then we put a dot on the y-intercept. We go over for a run of 3. There's your run of 3. And then your rise of 2. All right. And there they're going through what we just covered, and in more detail. Okay, now what they're doing is giving you another equation in standard form, and I'll write it out here for you. Plus 2y equals a negative 6. And they want you to identify the slope and the y-intercept. Well, again, the key is solve it for y. So on this side, I'm going to have 2y. I'm going to transpose this positive x to the other side, and it becomes a negative x. And my negative 6 stays there. Now I divide everything by 2. Now remember, there's a 1 that we didn't write, but we could write now. And dividing everything by 2. So this now becomes y equals a negative 1/2 x minus 3. They want us to graph this also. So we're sketching a graph. We want to plot the y-intercept, which is negative 3. Put a dot right there. Now this is negative slope. So negative slope, our run here, 2, will go to the left over 2. And then it's going to go up 1. And then this is our graph here. We know our y-intercept. We don't know our x-intercept. But we have 2 points is all we need to make the graph. All right, let's see what this looks like here. They do a nice job. Again, solve it for y, and there we have it. Now we're going to plot a negative 3 on the y-axis. That's your y-intercept. And we went over 2 this way and then up 1. But they're going down 1 and over 2. That is perfectly fine as well. And there is your graph. And you'll be practicing this. And they're talking about the procedure for doing the graph. Now, here's another example, example 4. We're going to use the y-intercept model to actually write an equation if we know the slope which they're saying is 1/2, and we know the y-intercept. So our model is y equals mx plus b. Well, we're just doing a little substitution. Y equals our slope, which is 1/2. We have to be sure to include the x, and we only include the y value here, negative 2. So using, if we know the slope, And we know the y-intercept. We can write it in this form very easily. Okay, let's just clear that and see what we have here. And there it is. So, these are some practice problems. We've already gone 25 minutes. So I'll leave this here for a moment. Pause it if you want to work on some. And then here are the examples. After pausing it, you can get to this. Okay.